So to start with, I'm just going to introduce our panel here. I know a few of you have seen the video that went out, but I'm just going to introduce them a little bit more. So we have Andrew Reid, who's our engineering manager and who has been with Hawke for 3 years, previously spending 2 years as a product design engineer. We have Sim, our certification manager, who has a mechanical engineering background and has spent at least 5 years within the hazardous area industry working with notified bodies. So Andrew and Sim, if you just want to give a little wave there as well.
Hello, please take it easy on this.
And finally, we have Matt, our technical product specialist, who has been with Hawke for around 11 years now and has a wealth of knowledge, particularly surrounding our cable gland and connector product lines. So that ends our introductions. Oh, sorry, Matt.
It's all right, cut me off.
So that ends our introductions. So we're going to kick off with our questions now. As I said, if you have any questions, please submit them via the conversations tab throughout the session, and we'll do our best to get to them. So first of all, we're going to talk about what different types of cable glands Hawke offers. So Matt, if you want to kick off with that.
Absolutely. Rather than actually going through kind of the individual cable glands that we offer, I think it's easier to split it down into component form. So if we think about kind of the inner and outer sheath of a cable, obviously each has a seal. We actually have 5 different sealing options. We'll start with the yellow or the orange seal, sorry, that you tend to see on the back nuts of cable glands. They're predominantly only for our armoured cable glands, and you'll see them obviously being used on these armoured versions. We have compression seals, and they can be used for IP seals as well. So on our unarmoured cable gland range, so our 501421 or our 501423, these are used. These are also used as an internal compression seal to give you your EXD requirement as well. So if you go inside of the cable gland, you look on the inner sheath, as I said, this compression seal can be used there too. Obviously, this is a mechanical type seal. This is an active seal, something where you have to apply some pressure to it for it to do its job. We also have the diaphragm seal, which is used in our 501453 universal range. This is a seal that was designed to reduce the effects of cold flow. Again, given this is your EXD seal in this particular type of gland. And then we have barrier glands, and we have 2 different types. One is a potted gland, where we can either use the express resin or a 2-part putty. That's where it's set around the individual cores and gives you protection around the individual cores rather than cable doing that. The other is our PSG range, which is essentially it's called a punch seal gland, and this is a slug of silicon that you use a punch tool to punch holes through. You pass your cable cords through there, and then you apply mechanical compression to that seal, so it seals around the individual cores themselves. You do have obviously other parts of cable gland, so an internal clamping ring that obviously gives you for grounding. These are obviously used for armoured and braided cables. Our reversible armour clamp allows for you to clamp onto braid, steel wire armour and tape. And we also have in our 7 series range, which is predominantly used in the US. We have the Diablo, which is a compressible copper cage, all inspectable. You're all able to dismantle the cable gland and inspect all of these components as well. There is a couple of extra pieces that can be added to particular gland types that give you the ability to terminate onto different types of cables, such as lead sheath cables, for instance. So we have copper tines that can be added to our 501453 RAC range and one of our barrier gland ranges, and that makes them suitable for lead sheaths. We also have special inner seals that need to be obviously thought about when you're specifying for specific cables, and if the cable inner sheath is relatively small in comparison to the outer sheath, and that may need to be used. And that essentially makes up our whole cable gland range. The components that we've just discussed is basically features in all of these ranges. The other one to maybe mention is our conduit range. These allow you to attach a cable gland and give you your EXD requirements for cables passing through conduits, whether that be fixed conduit or flexible conduit. With flexible, you would need an additional gland, and these Cable Glands are designed to have a female entry on the back that allows you to attach that additional cable gland for IP around the flexible conduit, and maintain obviously the integrity of your equipment or an enclosure.
I mean, something to add there is it's quite an interesting way to break down when you're going to select your glands. You know, what seals do you need? What armor clamping arrangement do you have? And generally, once you understand this, it'll point you in the right direction for which gland you need to use for your application. Because Hawke have thought about our range in that way, almost like a modular range, it's given us the ability to rationalize components between the different gland types. And then what that means is we've unlocked the ability to purchase a dual marked universal and ICG gland, and then have the ability to upgrade that from a universal gland to a barrier simply by swapping out components within the gland itself.
Absolutely.
Perfect. Does anyone else have anything else they'd like to add to that? Okay.
For me.
Good. Willie, with regards to your question, we did receive a couple of questions via our forms about that specific standard, so we will come to that question shortly and expand on it then. We do have another question from Ganesh here. We have a new type of cable type with ALHDP/PA sheathed Hylam cable. Is there any product to earth the aluminium layer of this cable?
To fully understand whether we could do that, I'd have to see a cable data sheet. Obviously, if you could send me the cable data sheet, then we can obviously review it and obviously give him some further advice on that. No problem at all. I'm sure we would do, but yeah, without seeing the data sheet to obviously get some physical understanding of what the construction of the cable, it's a little bit difficult to just do it off the top of my head on a call like this.
I mean,
Perfect.
aluminium armor comes in a number of different forms, doesn't it? So it's more about
Absolutely.
the form of the armor, not the material, that we'd have to understand.
Okay, perfect. Is that's so perfect? We'll get back in touch with you separately on that question, Ganesh.
One other
No?
point to make on that, Liv, just before you move on, just regarding obviously the aluminium armor and what have you, and the use of kind of obviously different materials and things like that. You know, we would always recommend that brass nickel plate would be used, or stainless steel. You know, never brass on aluminium armors, just because of the galvanic corrosion that could take place. So it's just worth mentioning, obviously, for everybody on the call, just to be aware of that if they are using any type of aluminium armor on there.
Okay, perfect. Good point, Matt. So moving back to what you were talking about regarding the diaphragm seal and compression sealing ring, could we talk a little bit more about the benefits of the diaphragm seal over a compression sealing ring?
Yeah, I mean, I was just going to say the important thing is to understand how these seals work. I mean, they're both effectively doing the same job, which is an explosion/gas seal on the inner sheath of the cable. A compressive sealing ring is kind of the more conventional arrangement that you'll see, which is basically a ring of rubber that the installer has to tighten up. So they are doing up a middle nut onto an entry and squashing the rubber in between to put pressure on the surface of the cable and form a seal. The diaphragm seal is what we call a passive seal, and it's actually like a cone shape. So what you're doing is you're pushing the cable through the cone and opening it up, and relying on the elastic forces of the plastic and the rubber of the cone to push back onto the surface of the cable. Important difference here is you're not relying on the installer to tighten the seal onto the cable. It's installed by design. Therefore, you can control the amount of force that's on the surface of the cable. It's very easy with a compressive sealing ring to over tighten the seal and put a hell of a lot of force on the surface of the cable, which is obviously not a very good situation to be in if your cable is particularly soft bedded. It's going to be very likely to try and move away from the seal under that force, and ultimately it can compromise your installation.
Which brings us to a question. Oh, sorry, Matt, I can let you finish. We've had a question from Marcus from Offshore Industries via our form. Thank you for your question, Marcus. He says many brands clearly print on their catalogues that their glands are cold flow compliant, whereas the Hawke RAC series, it's not specified. And he said this makes things really difficult when comparing E1FW with the RAC glands. Could you talk a little bit more to that based on the type of seals that they use?
Absolutely. I think, this whole issue of cold flow compliance, there isn't anything in the standards that relate to cold flow compliance. There is a statement that refers to cold flow, and it's about 4 or 5 lines long, and it essentially it's in part 14 of the standards, so it's for the installation standard, and it refers to the selection of cable glands, where you have to ensure that you select a cable gland to reduce the effects of cold flow. And cold flow is described in the standard as essentially pressure being applied, or an increased pressure, or the amount of pressure being applied to an inner sheath of a cable being greater than the resistance of the material that's being applied to. And if that happens, and certainly on these very soft bedded cables, and any kind of fire resistant, flame retardant cable that we see in the market tends to have this very soft bedded inner sheath, and it almost pulls apart like chewing gum. And if you do apply pressure to that, and our RAC is the process of installing that cable gland is exactly the same as an E1FW, and that's what causes the problems, because you can't manage that pressure. Whereas with the universal seal, with it being designed to reduce the effects of this cold flow issue, you can control the amount of pressure that's being applied, giving you the ability to ensure that you're doing everything that you can to reduce any problems that you may have, obviously, throughout the life cycle of that product.
Another interesting point on that, I suppose, is it's useful to be aware that through the process of certification, all the testing of cable glands is done on stainless steel mandrels, because that's considered to be a worst case scenario. The hardest type of cable possible is going to be a solid steel mandrel, which is what's used to do the testing. Now, we always try and consider, well, what happens in real life when you're putting the products onto a cable? Obviously, a steel mandrel that's been used to certify the products is not going to behave in the same way as a very soft piece of cable. That's kind of why we always recommend the diaphragm as a solution here, because not only is it certified and it works on a stainless steel mandrel, it's certified, well, we think it's an appropriate seal for use on soft bedded cable.
Absolutely. And one other thing to mention there is, the maintenance and the inspectability and maintenance of this particular seal as well. Because it's a passive seal, it's by design, it's in position, and it's there to do its job at the point when you install it on the cable. By the process of regular maintenance and inspection, obviously this can be looked at, checked on a obviously recurring basis. And these products are designed to last 25 plus years, so you're going to have done that process quite a number of times before you're looking to kind of rip out and start again, or change these products. So it's a case of ensuring that the product over its lifespan can be checked and maintained, as well as obviously ensuring it reduces any effects that it can potentially have on the cable.
Yeah, and Willie's made a really good point regarding cold flow. The installer must know the cable data as well.
The cable data, did you say? Sorry.
Yes, that's absolutely the comment in the chat.
Absolutely, and we find anything that's designed or been tested to a specific standard from the cable design standards, that it tends to be this soft bedded material, and absolutely the installer should know that. If not the installer, certainly the design people, to ensure that they're selecting the right cable gland and cable configuration at the point of the design process.
Mm-hmm. Perfect. Well, I'm going to, just because we've received a few questions on this, I'm going to move on to questions specifically about barrier glands. So one of the questions that we did receive was, in EXD applications, do I always need to use a barrier gland?
That's a good question, and it's something we often get asked about. There is various guidance in the standards on when you need to use a barrier gland. This changes depending on where in the world you are. The guidance in the British standards, for example, differs slightly from that in the IEC, and which again can sometimes vary in places like Norway. So the first thing you need to understand is, where are you and which standards are you trying to comply to? generally speaking, making a decision not to use a barrier gland in EXD will bring the arrangement of your system into play. So you've got to think about your length of cable. I think all the variants will dictate that you need a cable of minimum 3 meters in length. And you also need to consider how effectively filled is the cable itself. In the British standard 6079-14, which is the installation standard, there's some quite clear conditions there on what your cable should be. The filler should be extruded, and there's also guidance on how you can test that cable. So there's what they call the Annex E test, which is basically a restricted breathing test on the cable. And what that's trying to do is make sure that you're not going to get propagation of flames up the inside of your cable cores. Now, we would, always say, if you want to be completely foolproof, put a barrier on it. If you put a barrier on, you're effectively sealing between the cores of your cable, and you're not relying on the cable itself to do that job. I mean, even if you're confident that your cable is going to pass the Annex E test, how do you control that on site? Are you going to do this test on every reel of cable that you're installing? That's probably unlikely. So to answer the question, it's something that needs to be carefully considered, and there are avenues you can take to install non-barrier glands in EXD. But if you want to be completely safe, a barrier will always give you that protection.
I think there's tolerances in the way cable manufacturers manufacture the cables. You can see the tolerances on every cable data sheet, plus or minus however much percentage or millimeter or 0.0 millimeter, whatever it is. And obviously them swings in tolerances obviously have an effect on how compact, circular, these cables are. Obviously the extruded bedding obviously helps to keep everything contained. And that's obviously one of the caveats in that selection process. But you look at the Annex E test, and it's almost impossible to carry out that test on site on every reel of cable that's being applied. And I think you've got to take it with an amount of caution, because essentially there's no way of ensuring that cable comes in the same, has been manufactured to the same tolerances every time, because there's so much sway within the manufacturing process, and cable manufacturers are open about that. They have plus or minuses on their cable tolerances, which obviously has that effect. There's a number of other things like your braid coverage has to be considered, and a number of other things. And it's almost scares you into even looking at anything other than barrier glands. And without us being able to see a piece of the cable and possibly test it on the rig in Hawke, we could never say that a compression gland would be suitable. So from our point of view, I think, from a gland point of view, and people asking for us for advice, EXD, until we see the cable, we can't make any other comment than to say use a barrier gland.
I mean, we did have a specific question that was submitted through the forum. So that was from Mukund from Petrofac, who I know is on the session today. So he did say, with reference to the latest IEC 60079-14 2013 clause 10.62, he was asking whether for a typical oil and gas project installation, barrier type gland shall be applied for any EXD equipment if the connected cable length is less than 3 meters. This is irrespective of internal volume of the enclosure and the gas group. Can the requirement of barrier glands be diluted by the installation contractor by using the cable length in excess of 3 meters and EXD certified double pressure compression cable gland in non-UK based projects?
I think if the cable passes obviously all of the caveats in the standard, and it's longer than 3 meters, then absolutely, but it's ensuring that cable passes or meets the requirements and would be suitable for, and pass Annex E. Do you want to add some more on that, Andy?
I was just going to say another point there is he referred to the volume of the enclosure. 10.6.2 doesn't talk about the volume of the enclosure anymore. Actually, a lot of people still work to a flow chart, which is not actually part of the main standard anymore. It's just an advisory part at the end of the standard, which does talk about volume of enclosure and when you need to use a barrier or not. And yeah, that's kind of a little bit of a grey area because it is advisory. I think that's kind of to ensure that historical installations do comply, and I don't think anyone is really saying those installations are unsafe, but just be aware that it's not actually called out in the main body of the standard anymore.
I think that's been a growing concern for a lot of people, certainly from OEMs and operators and all the people obviously in between. Certainly for using compression glands and obviously previous installations, and there's been a lot of talk about how safe was it previous compared to now, and you know, about testing and things like that. And I know that that's obviously under discussion through the standard committees currently, and they're looking to bring back, I think, a more structured way of selection. Obviously we'll have to wait and see what that says when that's obviously issued.
I mean, Willie, you've had quite a few questions around this topic. Would you like to unmute yourself and ask a couple of those questions, or raise a few of the points that you've raised in the chat there?
Yeah, certainly. It's there's a lot of dispute within the IEC just now regarding the cable gland selection chart, which was removed from the 2007 edition. The present 2013 edition, of course, has this quite confusing statements as to when you want to pick a barrier gland over a universal cable gland. But I understand through the IEC technical committee that there is no justification being identified scientifically for the removal of the cable gland selection chart, which was very, very easy to follow. Installation guys found it extremely beneficial when they were on site to say, is it got ignition capable equipment? If not, then it's a universal gland. Is it in a zone 1? Is it in a zone 2, 2A, 2B gas group, etc.? It was so easy to follow. And my understanding is, having spoken to members of the IEC, that the chart will be reinstated in the next edition.
That's I think that's the word on the street, is that that's going to happen. Yeah, I think I completely agree. I think, you know, a lot of people have stood up and said exactly the same thing as you just mentioned, and yeah, I know that it's obviously being looked at. I think the flow chart is being looked at in a little bit bigger sort of kind of, there's more selections to potentially make, but essentially gives you a nice easy guide, go no go type flow chart that obviously makes it very easy for that selection to happen.
Yeah, I agree.
Okay, perfect. And just touching back on using a barrier gland in general, could we talk a little bit more about installation requirements and training as well?
Yeah, there's big problems within projects worldwide. Now, Hawke, I know very, very well from Singapore and various other locations in the world, and work very closely with Hawke. One of the questions that's always crept up is, okay, we give universal gland training when we're in Keppel shipyard or whichever shipyard you're in. But what seems to be excluded is the project won't ask for barrier gland training. Now, the barrier gland is a completely different animal. Yeah, it's a much more technical piece of equipment and you have to get it right. You've got no labyrinth seal there. You've got this 20 mil of epoxy resin that has to be right. If it's not right, it fails. Yeah, and to be able to get a selection of people on site that only install and inspect barrier glands to guarantee that it is correct is really important.
Absolutely, I think you know, installing barrier glands is absolutely more difficult. You know, it's the process is much longer. It's much more, you know, there's much more involved in that process, and getting that process correct is obviously imperative to ensuring that you maintain your protection. You know, obviously we stand by the fact that we offer global training, and you know, we currently obviously we can't at the minute, but if there is any requirements anywhere in the world, obviously we can obviously ensure that we service that training requirement, and obviously train on barrier glands should they request it. But yeah, absolutely, I think if you're seeing a problem out in the field, then obviously that needs to be addressed, and we can obviously do what we need to do as and when we can.
Absolutely. I was just going to ask one other question on barrier glands, which I've put on the screen tonight anyway. But how many people in the audience tonight know the difference between a barrier gland and a universal cable gland by looking only, visual inspection? What's the difference?
So how to notice the difference, or
yeah,
how many?
I know how to notice the difference.
Okay.
I'm just asking the floor. Do you know what the difference is? Just by a visual inspection from 20 meters away, can you tell?
Absolutely. I mean, between obviously the universal and the ICG, you have a visual, a coloured band around it. We call it the deluge boot. That gives you a visual indicator as to which cable gland is installed. We use red for barriers, and we use black for universal cable glands. So it's a easy visual indicator. As long as it's not covered in obviously dirt and filth from the environment, then obviously you should be able to see that quite clearly.
Yeah, thank you.
Yeah, to add to that, I mean, I think it's important to have competency when it comes to installation. So obviously, if you don't have, you're only as good as your installer. You know,
absolutely.
No matter how good the cable gland is, if the installer is not good enough or not competent, then we've got a problem.
Competency is key, I think, without doubt, and ensuring that all of your installers are trained to a certain level is obviously absolutely imperative to ensure you're not going to get future problems down the line.
I mean, that's something we're constantly thinking about in the design of our products, is to try and make them as foolproof as possible. That's, you know, how we ended up with things like the inspectable compound pot and the external tightening guide, is to try and make the installation of these products as easy for the user as possible. But, you know, ultimately competency is a big part of correct installation.
Absolutely. We're now running slightly over time, but I know that quite a few people did ask specifically about the express resin. So I just wanted you guys, before we finish, to talk about the differences between Hawke Seal Express and PSG barrier glands. Those of you that have submitted questions within the chat, apologies, we will make sure that we get to those. Either we'll respond to you individually or we'll bring those up in the next session as well. Sorry, Andrew, carry on.
Yeah, so just to quickly summarise, I know we're running late. We do offer really three methods of barrier. We've got the conventional Hawke Seal 2-part epoxy putty, which is really like a 2-part blue tack material that you roll in your hands and have to mix together and physically pack around the cores of the cable. We've also got our new liquid express resin. So this starts life as a 2-part liquid that's in a cartridge, and you dispense this by hand. The cartridge mixes a material as it's coming out, and you pour it into the gland itself, and it will flow around the cores. And it's a nice dark colour with a high contrast, so you can actually see it. You can see it flowing. You can understand how much material you've got in the compound pot, etc. Both these types of barrier are installed into our silicone compound pot. The silicone compound pot is transparent, so you can actually see the compound as you're making it off, which really is a massive help to ensure you've got no voids in the material and you've got the correct amount of material in there. And then finally, as Matt touched on earlier, we've got a PSG barrier gland. This is actually a solid slug of rubber that you have to physically punch holes into to accept the cores of your cable. The benefit of this gland type is you don't have to wait for your compound to cure. Once it's installed, it's good to go. Whereas both the putty and the express resin do have a cure time associated with them. Downside is it's quite limited on the quantity and diameter of cores you can put through it, because obviously you have to put holes in there to suit your cores. So some pros and cons between all those.
I think one thing to mention just on the back of that is obviously the 7 series range. Previously, by standard requirements, we had to have a brass component in that compound chamber. Now, obviously, inspectability is a big part of every design that we do, and elsewhere in the world with the ICG cable gland range, we've always had inspectability there. Obviously, with the addition of this new resin, this clear compound chamber, we've managed to pass all tests for NEC requirements, giving the very first transparent, clear, see-through compound pot that allows for people in the NEC world to have some kind of inspectability rather than it just being a brass component that you can't see where you're filling, how it's filled, and that process makes things obviously a lot easier.
And just in terms of the resin, we did get a question about how the Hawke's resin barrier compares to the rest of the opposition in terms of curing time, shelf life and storage condition. So if you could quickly touch on that, Andy, as well.
Yeah, so storage condition is comparable to other liquid resins that are on the market. In terms of shelf life, we've got a 2-year shelf life on the product. It's worth saying that those storage conditions are recommended around 20 degrees ambient, I think, off the top of my head. If you were to store it in hotter conditions, you don't actually damage the resin itself, but you can potentially shorten the shelf life by around a third. On cure time, our cure time is a little slower than some competitor resins, but that's intentional. So this resin is formulated for our applications, custom formulated, and we didn't want it to be going off too quickly because we want to give the installer the opportunity to fix any issues you might have when it's pouring. You know, if you have a bubble that you want to try and move around and get out of there, you have time to do it before the resin cures. So it's obviously much faster than the putty. Putty is around 4 hours, whereas the resin is circa 20 minutes, depending on ambient conditions. So it is a lot faster than what we've got out there, not only in cure time, but also the speed that it takes to install.
I think one thing to mention on that, just about what the difference is between workable time and cure time. Obviously, you have the point in which it's still liquid and can be moved, but then it has to go through a process of gel and then a cure. You know, and they're set out in our AI sheets as to how long it might take in different ambient temperatures, and there are different times. Obviously, as the exotherm reaction starts to happen, it creates heat, and obviously it starts to go off and gets thicker, and then eventually it will gel, and obviously everything becomes very spongy before it goes solid. So yeah, cure time is obviously at the point in which you can install it. Gel time is obviously your working time for that, and which is around, from my experience, in normal ambient temperature about 20 degrees. You're looking at around 8 to 10 minutes for you to be able to turn it horizontal where it won't pour away.
Perfect. Anything you'd like to add to that? Anyone? Okay, I'm just going to quickly, I know we've obviously overrun, but I'll just quickly go through some of these questions that have been added in the chat that relate to obviously the topic that we've been discussing primarily. So Eduardo has asked, once we're using the barrier cable gland, can we consider that it will meet with the IEC 60079-14 requirements without additional assessment of the cables, of course considering that the cable are meeting with item 9 requirement?
As long as the cable gland fits the cable and you install the barrier gland as per the AI sheet, then absolutely it meets that standard and would be your, you know, your kind of fail-safe gland type, if you like, if you're competent enough to be able to install one and you've had experience of doing it before, definitely.
And Gunnar has asked, technically speaking, there is a constructive difference between EXI and EXE cable glands, Universal 453, and how do the EIC 60079 standards family explain this? So I think that was, is there a constructive difference between EXI and EXE universal cable glands, and how do the IEC 60079 family of standards explain that?
I mean,
well,
is that correct?
EXI doesn't really cover cable glands per se, so there isn't really an EXI cable gland, if I can say that. So requirements of EXI are predominantly to do with IP, which EXE covers. Yeah,
I think there's a selection table somewhere that will say you can use an EXE cable gland in EXI purely because it meets it, as Sim says, the IP requirements.
I think that's I think it's 10.6. I think there's a table 10. I think it may be in that particular standard that states that. It basically covers different types of concepts against different protection concepts of your cable gland, and gives you a table as to whether it would be suitable for that installation or not. EXE and EXD are both suitable for EXI, as well as EXNR, for instance. Obviously, there's probably a conversation on that coming up on one of these forums with regards to EXNR Zone 2. But yeah, absolutely, with it being Zone 1, that's obviously perfectly able. You're able to use that.
Perfect. Okay, well, I think that's all we've got time for today. Oh, just had a thank you, Chris, there. EXI is designed for zone 0. If it is zone 0, you shall stop the potential gas migration through cable to zone 1 or zone 2. So the EXI gland must seal. Would anyone like to comment on that?
Sim, do you want to cover that?
So what was the question again?
EXI is designed for zone 0. If it is zone 0, you must stop the potential of gas migration through cable to zone 1 or zone 2. So the EXI gland must seal.
So the question is EXI gland must seal? I don't
Chris,
understand.
would you like to?
Yeah,
Oh,
this prevent the migration of gas through different zones. So obviously that's something to be aware of when you're selecting your cable gland. Something like Universal would do that. It's got an explosion seal inside it that can obviously take much higher pressures than those you encounter during gas migration. It's also worth saying, talking about different protection concepts, to try and clear up some of the confusion that we get with things like EXNR, we have had our core gland range evaluated for use in EXNR, to ensure that we can have a notified body that states that they're suitable for that application.
Well, Chris will, like you said, we'll take this up with you offline as well. That is all we have time for today. Anyone, like I said, anyone that has submitted any additional questions, we'll make sure that we get in touch with you separately, or make sure they feed into our next session as well. Thank you all for joining our first Q&A session. Hope you all enjoyed it.
Thank you.
Thank you.
Yes.
Thank you.